Okay guys, this is another walking talking mock I'm going to do with you to help you improve your grades, and it is Unit 1 Construction Technology. It's a 1 hour paper. The later papers are slightly longer, 1 hour 15 minutes, sometimes 1.5 hours. It's a ballpoint pen you should be using, and complete the boxes as they ask, and be precise about that. So it's Unit 1 Construction Technology, and this is a sample paper, okay? And I'm going to take you through each question, and I'll go through each question with a little bit more detail than you'd normally be asked. And the reason is I can probably give you some answers to other areas of the paper as we go through, and similar papers, and that's the important point. So I'm going to use this ballpoint pen. It's black, and that's what you should be using. Okay, so read the questions very carefully, highlight the points as you go through. I've got some model answers that I'm going to be going through with you to help as well, but it's very important that you read and understand the terminology, the wording, and I'll be explaining some of these points as we go through. So, question 1. Many functional elements contribute to making a building safe, secure and sustainable and comfortable. Okay, you know what safe means. Secure means obviously one that isn't open to people entering that shouldn't be entering, and sustainable is a word used meaning materials used to protect the planet in some way. Okay, materials that perhaps don't damage the planet or Earth in any way once they've been used, or even as they've been processed into another material. Okay, so uncomfortable, obviously I hope you know what that word means. So there's some 4 keywords there that you need to think about. And it says match the property to how it is achieved in a low-rise building. Low-rise is normally up to about 3 floors, okay? 3 levels. So, easy peasy, I think this one. And we're looking at these answers here. Developing a brownfield site, which one's that most suitable to? Well, let's have a look. Sustainability, is that suitable to any of these? Provision of artificial light, can be, I suppose. Developing greenfield space, yes, possibly. Construction of a suitable foundation, not really. Provision of energy, not really. Developing a, well, that's the most appropriate to sustainability. That's where you're protecting the damaged or further damage to the ground. You're not using any new ground, so I think that's probably the most logical one. So I'll put an arrow there. And stability is a term used to explain how stable or how secure or how structurally founded or grounded the building might be. Okay, I think it's hard to explain that stability. So if something isn't very stable, it's likely to collapse. Okay, so something very stable. Let's think what's most important. Well, it can only really be this one, construction of a suitable foundation, because all the others aren't really suitable. Okay, so we could have got that wrong if we hadn't thought about it, but there we go. Okay, and I suppose the key really is there, the foundation, it's to do with stability. Okay, B of part 1. Complete the sentence about U values. A U value is a measure or value of the heat transfer or loss through a building material or any material. Okay, and it's a value of heat loss. Okay, let's have a look. Oh well, here we go. It's not to do with load, not that one. It's not to do with fire resistance, although they may actually have a connection with fire resistance in some way, and sound resistance, but it's all to do with heat loss. That's what it's all about. Okay, it's a measure of heat loss from a building. And C, outline 2 methods of making sure windows can resist the weather. Well, that's quite a difficult one to some degree to explain, but to resist means to stop or reduce in some way. So to resist I'm going to put means to stop. Now you wouldn't write that necessarily as an answer, but I'm going to write that in. And I think it's important that you know this, so it's good to write it down when you do your model answers. Or stop or reduce water flow, okay? And the answer could be correct LED flashing. Look up LED flashing, okay? And it should be used at the top, possibly the side, and even the edges. All depends really how the window has been designed and how it's been put in. It's normally at the bottom and to the sides. Correct vertical trays, okay? That's another important one. Correct vertical trays. And I'm going to put membranes. And I want you to look at membranes, okay? And another point here, a carefully added line of sealant, could be a mastic, if specified. Now I say that word, if it's specified by the architect. If it's properly designed, often windows don't need sealants. They tend to just use the LED flashing, but some might actually require some sort of sealant. So look up what a sealant is, and there's various types. What else have I got? UPVC LED flashing, correct use of sills. I'm going to put this correct use of sills. Okay, and sills come in various forms. Let's draw a sill as the window. Coming down, symbol for the window. It will sit inside a window sill on the inside, and often the window sill sits slightly lower like that, and then the wall with the cavity carries on and the plasterboard there. So that would be the brickwork. That could be the block work. Plaster here, and then insulation here. Okay, and often you have the flashing here, LED flashing, is often tucked in here, and it goes down the wall here as an extra piece. And often here, there's actually a cavity tray to stop any sort of water seepage. And this is the symbol for the window. There's the glass. Look, yeah, sorry, that's a bit of a mess, but sits in a nice, proper, deformed sill. And this is often wood or PVC or so forth. And then the window sill might actually sit on top of that as well. And that may be plastered actually over there. Okay, same along those lines. But look at the detail. And there's plenty of books that you can find some a little bit more a better detailed drawing than that. Okay, so, and then moving on to the next question. Identify 2 construction methods used to slow down the spread of fire in a building. So read these questions very carefully. Slow down the spread of fire, that's the clue. Right, I want you to look up compartmentalisation of buildings. That's how it's done. And barriers to stop heat flow and heat transfer, and smoke as well, of course. Wet risers are used, but these are active systems. These are connection systems which are used with the fire service. These are passive. These are designed into the building structure. Okay, and there's an active one, isn't it? smoke detectors and fire alarms. These are active ones. So these are actually designed within the building to stop the spread. Okay, the actual spread, whereas the others are really sort of sensors, if you like. Okay. Right. In the UK, which is the best direction for a building to face to make the most use of natural light? Well, in the UK, the only answer actually is south-facing. If you're south-facing, you get most of the light for most of the day. Okay, so let's move on. Right, well, there's some good points here I think we're making. You're learning as you're going along, I hope. Okay, this is question 2. And it says, a scaled site layout, how a construction site may be laid out, layout plan, that's looking down from the top, a bird's eye view, is used to plan and plan the preparation required on site prior, that's before, prior to work starting, so that's before work starts. Name 2 welfare facilities that should be shown on a scaled site. Scaled means it's just scaled to size, so you could actually put a ruler to it, a scale ruler, and actually work out the actual physical size of the site. Okay, and it's often 1 to 200 layout plan, but it can be bigger and it can be smaller. Okay, but look up scale. Your tutor should know, talk to you about scale. Okay, look up that word. Right, okay, so obvious facilities, what do you must have toilet facilities, and you must have canteen if it's a large site, and seating. And I'm actually going to put down first aid is something that is a must these days. Okay, things that you need to have in place in order to have a site running properly or effectively, that's a word. Right, moving on. A substructure design engineer needs to identify the component parts of a foundation drawing. Okay, foundation drawing. And this is a foundation drawing. Okay, label the parts of the foundation cross section. So this is looking through it, like you cut it through with a knife. Okay, now this question a lot of students seem to get wrong. And let's look. This one here is a DPM, and it's a vertical one and a horizontal one. Damp-proof membrane. It's a plastic barrier which separates the groundwater, like the earth moisture, from the actual building structure. Okay, and you often have here along the top then another one, and this is actually called the DPC, damp-proof course. Damp-proof course, damp-proof membrane. The membrane is a larger sheet, but the course runs between the brickwork layers. And it's normally about 150 millimetres high at that point. 2 bricks, roughly, from the ground level. Okay, so this is the cavity fill. Just mass concrete filled in there. Okay, and it should be sloping towards the outside of the wall. This is outside. So any water that may drip down the cavity then tends to flow outside, not towards the inside of the structure, the wall structure. This symbol here is earth. Okay, now these are usually concrete blocks that go down to the foundation here, but it could be actually concrete itself, but we'll put solid blocks, solid concrete blocks, but it could be mass concrete and the holes being dug for the strip foundation all in one go, and then they backfill it and then come up. Okay, but you know, in this case they've decided to use high density concrete blocks, and these have to be structural concrete blocks, not low density. And this is your strip foundation, and it's made from mass concrete, and it's a strip foundation. Okay, this is the very dotted line there, very small dotted line. It's a screed. I'm pretty sure that's a screed. Oh, it could be a sand blinding actually, I think. I'm going to put blinding. A thin layer of sand and cement. Usually dry mix. Blinding. Some might say it's a screed. This is insulation. Okay, and then obviously you'll have hardcore and you'll have a concrete concrete strip under here and hardcore. Okay, but it's not asking for that at the moment. Damp-proof insulation. So I think we've done that. Not very well drawn, I don't think that, but that, I'm pretty sure that's an insulation. And often you'll then have, you know, if that's a solid floor, you may have a concrete layer. And then you may have your hardcore underneath. Okay, not the best of drawings anyway. Okay, I hope that helps. Right, okay, so what type of foundation is that? What is the name given to the foundation shown in the cross section? There's the cross section, and we've just labelled it, and it is a strip foundation. If it was a deep strip, this would simply be deeper, down to here. Okay, but it's a shallow strip. Okay. Right, next question. Okay, hope we're doing well. Sketch a diagram of a cross section again through an external masonry cavity wall. Right, that's an outside wall. Masonry is brickwork and blockwork, and a cavity shows the hollow in the sense between the two layers. Quite easy. Let's draw this. It's actually drawing it for you there, look, in effect. And when you're doing your answers, often you'll find the answers can be found on another page. So do look as you go through. Draw nice and neatly so you've got your insulation. And you have your brickwork. And you have your blockwork. Now when I was younger, this used to be simply like that, but apparently the hatching has changed to that for blockwork now. And for plaster, you can probably get away with a few dots. So, plaster, this is inside, therefore this is outside. This is brick work. That's your plaster. That's your insulation. This is above DPC level, of course. Insulation. This is your block work. Okay, I think that covers it quite well. And of course, every 4 courses roughly you have what we call a metal wall tie that connects in between the two, like that. And it ensures that the building as it goes up is stable all the way up. It stops any likelihood of the brickwork and the blockwork, in a sense, changing shape. Okay, it's called a wall tie. We'll put one in, we'll label it. There you go. Every 4 courses, roughly. up and every about 1.5 meters across. Right, good. Right, we're going to do question 5 and 6, and then I think we're going to do the next part of the paper in part 2. All right, so this is really our part 1. Okay, timber frame construction uses a secondary finish which is applied to the outside of panels. Okay, timber frame construction. Give one secondary finish which keeps out the weather. Oh, this is quite easy. So secondary finish. Okay. It could be UPVC weatherboards. It could be the new composite boards you see as well. It could be render, which is the concrete stroke mortar external finish you see in a lot of buildings. So it's more of a masonry finish really, isn't it? You could use wood, so it'll be cedar cladding. And you could use brickwork, because the timber frame is going to be on the inside, because it's timber, so you could have brickwork if you wanted to, brick and timber. Try the outside of the panel, yeah. Outside of the panels, well, yeah, brickwork can be. And actually, I say brickwork, it can be pre-made, and you can actually use very thin sections of brickwork called thin facing sections, and they're not full thickness. It's all very carefully moulded on to the timber. I've seen it, it's very clever. It's not full thickness of bricks, actually 30 millimeters, 20 millimeters of just brickwork looking panels. Clever, look into that. Right, perhaps explain that in your answer so that you don't think it's just chunks of bricks glued onto the wooden section. That wouldn't probably get you the mark. Okay, let's move on. An architect, the designer to some degree, is more the aesthetic designer, not the structural designer, is designing a house, and it is considering 2 types of floor. Explain 2 advantages of using a beam and block floor instead of a solid floor. Beam and block, okay, beams obviously used, and blocks are used to infill in between over solid concrete floor. I think that's what it's assuming. This is worth some research, please. Research these 2, a beam and block, and a solid floor, please. Right, let's have a look at the beam and block. Okay, the beam and block is quicker to construct. Beam and block is quicker to construct. And therefore cheaper. On both labour, that's the workers, and materials. Yeah, labour and materials. Good. So you could put an example if you get time. You could always go back and add extra detail if you get time in the exam. Less concrete used. Less stones. Spoke hardcore even. Okay, and the beam and block looks like this. Here's a beam. Just looking at down the end, the sectional view. There are your I-beams. Well, it's half an I-beam, isn't it? Usually has a bit of reinforcement in them. reinforcement is the steel you see sticking out of concrete often. Going down the ends, there's the beams. Yeah. And these are obviously 10 metres long, most of them. Depending on the floor's design, of course. Does that help? Yeah. And then in between, they'll have blocks. Okay? Large concrete blocks. Lots of them. Okay? Just concrete block. Hope that helps. And then the whole thing is screeded over with a layer of concrete right over the top. And there'll be, you know, it goes much, much wider. And then it could be 10 metres in this direction. And it could be 20 metres in that direction, depending on the size of the floor. Okay? Now, the other good point is you can construct a beam plus block floor. I've only done that to speed things up. Beam and block floor all year round, and that's a really important thing, all year round. So even in the wetter months of the year and the colder months. Okay. Some of the other types of construction, you can't just pour concrete in all weathers. You cannot pour concrete below, this is 5 degrees centigrade. That is, concrete cannot be poured below that. No concrete pour permissible. Okay, that's an important point. So even if it's at 8 degrees, it could be that during the day the temperature drops down further and it's not allowed. Okay, so it's not permissible to pour concrete even around that 5 degree mark. Okay, so winter might be out for a solid concrete floor. Okay, might be out for that. Right, last one here. Explain how the installation, I nearly read it on, the installation of a damp-proof membrane, we heard that earlier, damp-proof membrane, DPM, prevents moisture transfer in a solid floor construction. Right. Solid floor construction is actually quite a complex thing to get your head around, and you find that it's not as straightforward as you think. So let's have a look. Here's your beam and block. Okay, and there is your solid floor. Okay, it shows a raft here, but it's a solid floor. And there is the damp-proof course, and there is the damp-proof membrane. It shows actually the reinforcement steel in here, doesn't it? The beam and block floor, because it's not on the actual earth, if you like, and it's slightly away where it's ventilated here, it doesn't have necessarily a membrane, but it should do on the best ones. I would suggest that a lot of architects would specify a membrane as well. It doesn't show on there, interestingly. Okay, right, so on solid floor construction, let's have a look at another one. Some more foundations. There's one there shown. There's one there shown on the solid floor as well. Okay, could book this actually. Right, so study that. You can see that there. You can stop the video at that point and have a look. Okay. And there's some really good points about it. Right, brilliant. Explain how the installation of a thermal prevents moisture. Well, simply because the DPM is made from plastic sheet and does not allow water to pass through. Okay, it is impervious. Okay, it's impervious. It won't allow water to pass through it. You need to consider the correct thickness. So, correct thickness is necessary. And the reason is, if it's too thin, it can puncture and things can puncture through it. So let's have a look. If you put a membrane down there on concrete and you have some sharp stones, it will puncture the polythene layer, okay? And that's what you don't need. So it's quite a thick layer. It's something you can't rip easily with your hands, all right? What else would you have to do? Plus, you must, it's important, okay? Lap edges. Okay, you must lap the edges. You got that there? Lap edges. And it's normally EG 150 millimeters. And that's the min. 150 mil. And the lapping, if you can see this, you'll have a piece of polythene there. Big sheet of it. You'll lap it there. Another piece. And often you then tape it with a PVC tape. Okay, this is your fabric. Well, you put your plastic sheeting. Okay, right, we'll do the second part of the paper later, so we're not doing too much in one go, but I want you to look at some of the points I've made. Study perhaps the wall ties. Look at the types of foundation. Okay, and let's have a quick look. Yeah, types of foundation. Okay, deep strip, raft, piled. Pad foundation isn't shown in this book actually, but it's basically a square chunk, if you like, or pad of mass concrete with reinforcement in, often not drawn there, but in a sense it's a square of concrete, usually about a metre deep by about a metre square. Okay, it's not in that book there. Interesting, they want to research. And the shallow strip foundation there with one piece of reinforcement bar. Often it's a bit more than that, and often it's a matted bar, you know, so you have quite a few layers of reinforcement, but it's matted, right? Okay, right, stop the video there and perhaps look at some of that, can't you? So what else have we got? We looked at the DPM and the DPC, damp-proof course, damp-proof membrane, the blinding, which is a sand stroke dry mix, that's worth looking into. And there's that floor there. It's not really detailed as well as I hoped. Perhaps doesn't show. Oh yeah, it does. It shows the insulation and concrete above. There's some, yeah, can you see how that diagram could be better? Anyway, facilities there. I wanted you to look at scale of drawings. Get types of drawings, get location drawing. You get site layout. You get sections. You get presentation. vegetation drawings. You get elevations. Okay, all these you get site layout, location. You get block drawings, block plans. So look at those. Yeah, a bit of research for you. Often comes up. Okay. TION. Okay. What else do we look at? Oh, weather resistant. Oh, LED flashing. Look at LED flashing here. Look at LED flashing. Lead obviously is a metal and it can be soldered on site, but not soldered like electrical soldering, but it can be soldered and planished into shape, folded. We looked at sealants and window sills, how to reduce the spread of fire, but passively within the design, not with added wet risers and smoke detectors and fire alarms, passive ways. Design within the building. Look at compartmentalisation and barriers. South facing for UK, best direction for UK light and sun, heat. And we looked at stability and sustainability. Often they use words that are similar and try and get you confused a bit. Oh, and U value. Look up U value. Okay? All about the heat loss. Anyway, I hope you enjoyed that. I enjoyed doing it. I think I've learned or reminded myself about a few details. But let's look for part 2, and hopefully part 2 will show you all the remaining marks that you can gain from this sample paper. Thank you.